Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with some algebraic equations, and with that in mind, let's get straight into the first one. So the first one they've given us is solve for x, but the tricky part here is they haven't given us any numbers, they've just given us letters. So I'm going to write out the question, equals a. Alright, so now we need to solve for x. Now, even though we only have letters and variables in this question, the approach we use does not change. We need to get x by itself. Now what we can do on the left-hand side, I don't know if you've noticed, but we've got an x in both of the terms, which means there is a highest common factor of x. So let's pull out an x, and we are left with p plus q equals a. Now in order to get that x by itself, we're going to divide both sides by p plus q. And obviously that p plus q cancels out, and therefore x is equal to a over p plus q. Nice and simple. Right, before we move on though, we need to make sure that we tell the marker there's some sort of restriction about these variables in the denominator. We cannot afford the denominator to be 0, because if that is 0, then it's going to be undefined. So we need to let the marker know that there is a restriction. And the restriction is that p cannot equal minus q. If they do, if p is equal to minus q, then we know that there is going to be 0 in our denominator. So we cannot have p equal to minus q. Very, very important to let the examiner know that. Right, let's move on to 2.1.2 now. So 2.1.2. Right, so in 2.1.2, we've got 2x squared minus 5x plus 2 equals 0. So the first thing I notice here is I notice that there is a trinomial. So I'm going to use some trinomial factorization in order to factorize it into two brackets, which makes our job, our life, a lot easier. Now, a tricky part with this factorizing is we've got a coefficient in front of our x squared. So here we're going to use the butterfly method, and I'm going to use 2x over x. And on this side, because I've got 2, what two numbers multiply to 2? Well, that's going to be 1 and 2. I'm now going to cross multiply, and I'm going to be left with 2. So I've got 2x times 2 is going to give me 4x. And then I've got x times 1 is going to give me x. Now I need to get to minus 5x. So that would mean I need a minus there, and I need a minus there. So that means I need a minus in both of these, and these form the brackets that I'm looking for. So therefore, 2x minus 1 times x minus 2 equals 0. Therefore, either 2x minus 1 equals 0, or x minus 2 equals 0. And that would therefore mean that x equals 1 over 2, or x equals 2. Now remember, if I plug these back in, so if I've got x equals a half, if I plug it back into there, this bracket becomes 0, which would mean the whole thing is 0, which means the equation is proven true. If x equals 2 and I plug it into this, 2 minus 2 gives us 0. This whole thing becomes 0, which is equal to the right-hand side. I'm going to need a little bit more space for the next question, so pause the video and rewind it if you need to watch that again, because these are really important and they will come up. So give me a few seconds now to erase what I've just done. And feel free to fast forward during this period of time where I'm erasing the stuff. Good stuff. Okay, let's move on to our last one. So we've got 2.1.3, and that's going to be 1 over 2 to the 3x plus 1 equals 32. Okay, now remember, when we've got the exponent, when we've got the variable in the exponent and we need to try and solve for that variable, we need to make both sides' bases look the same. How could we do that? Well, I'm going to leave the 1 over 2 as it is, And I'm going to try and work with this 32 in order to make it look like this 1 over 2. So 32, how can I write it in terms of 2? So if I think of it, I've got 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5 2's being multiplied together. So that means 32 can also be written as 2 to the 5. Okay? But can you see we still don't have the same base on either side? So I need to do one more thing in order to make them the same. Do you agree? In order for me to make this 1 over 2, I just need to change that exponent to a negative. So it's going to be 1 over 2 negative 5. Right, now you can see that I've got the same base on either side. And that means this must equal this. Right, so therefore, 3x plus 1 must equal minus 5. And now I can solve it the way we always solve it. 3x equals minus 6. We divide both sides by 3. And that's going to give us x is equal to negative 2. Nice and easy. Those are some good marks in the bag. Remember, these will always come up. So make sure you really have a good understanding of how to solve for x in each of these cases. Thank you so much to our sponsors for making this video possible. Read all about them in the description below. Remember to check out our website for more of these epic tutorial videos. If you can't find the answer to your question, remember you can send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.